Alright guys, so today we're going to be looking at the quadratic formula and also the discriminant and talking about what all of that means. So our goal is to be able to solve the quadratic equation using the quadratic formula. We want to also be able to analyze the discriminant and determine the number and types of solutions. Also want to be able to solve real-life problems with quadratics. So you have to memorize the quadratic formula. There is a song which I guess I will sing to let you know how it goes here in just a minute. The discriminant in the quadratic formula is this b squared minus 4ac part. Alright, so here it is, the quadratic formula. If we have ax squared plus bx plus c equals 0, we can find the value of x by doing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, a little pitchy, but you get the idea. Alright, so analyzing the discriminant. If this b squared minus 4ac is greater than 0, we're going to get two real solutions. Now, this should make sense if you think about it. So let's just say we've got let's say that A is 2, B is 3, and C equals 4. And we start doing the quadratic formula, negative B plus or minus the square root B squared minus 4AC all over 2 times A. Alright, so look at this. This part's the discriminant. If this part is greater than 0, which is not going to be in this case, but if that's greater than 0, we're going to have two intercepts. We're going to have that negative 3/4 plus or minus whatever this is, right, all over that. So that's why we're going to get those two real solutions. Now, think about it. Suppose this had been 0 under here. Well, then our only answer is going to be negative 3/4 in this case. Okay? So one real solution. Now, if this is less than 0, which is what we're going to get, like let's say I finish this problem, negative 3 plus or minus, this is going to be 8 times 4, that's 32, 9 minus 32 is going to be negative 23 all over 4. So look what I'm going to get, an imaginary solution there. So whenever under that radical, that discriminant is less than 0, that's when we're going to get two imaginary solutions. No x-intercepts in that case. We have one x-intercept here when we have that 0, 2 here, none here. Alright, so let's look at it. So we're supposed to use the quadratic formula to solve, so we've got x squared minus 7x minus 18 equals 0. Now, I don't know why in the world you would ever use a quadratic formula if it can be factored. You always want to check that first. You know, the book is going to say use the quadratic formula to solve like this, but I'm not going to. Are there numbers that multiply to be 18 and subtract to be 7? Yeah, so let's do it. We got x and x, we got 9 and 2, we got a negative and a positive. There are our two solutions. No sense doing the quadratic formula. Checking this one. Numbers that multiply to be 6, 3 and 2, 6 and 1. None of those are going to subtract to be 4. So can't do it. Going to use quadratic formula. A is 1, B is negative 4, C is negative 6. So I'm going to do x equals negative b. Opposite of that's 4. Plus or minus square root b squared minus 4 times 1 times negative 6 all over 2 times 1. Alright, so now I'm going to have 4 plus or minus the square root of, this is 24 plus 16, that's 40, all over 2. Here's our discriminant, greater than 0, right here, so we should get two real solutions. So just finishing this then, I'm going to get 4 over 2 plus or minus, radical 40 is 4 times 10, so that's 2 radical 10 over 2. So our two solutions then are going to be 2 plus radical 10 and 2 minus radical 10. Those would be the two solutions. Now, let's say I'm like taking a big test. I have to get this problem right. I'm just determined to get it right. Well, I'm going to check it. X squared minus 4x, whoopsie, wrong button, minus 4x minus 6. Put that in there. Go down to y equals again. Put in 0. This is these numbers are pretty small, so I'm just going to do a zoom 6. Here's the way it looks. These should be x-intercepts, right? So I'm going to compute those x-intercepts, and since I put in y equals 0, the quick way to do it is second trace, calculate, and I'm going to find that point of intersection, get kind of close to it, enter, 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 and the intersection is at negative 1.162278. Well, that's probably this solution. I'm just going to check that one to be sure. 2 minus radical 10 is, wonderful, negative 1.628 if we rounded that up. So that was the same thing. We should be correct. If I had to estimate this, I could say radical 10 is about radical 9, so I know that this answer is going to be a little bit bigger than 5. Just a little bit bigger than 5. I could check it out, make sure it is. Remember how we check it? I'm just under that graph. I'm going to go over to this solution. I said it should be a little bit bigger than 9. Let's make sure it is. Oh, I'm sorry, I said 5, not 9. Enter, enter, enter. And yep, a little bit bigger than 5. We're good. All right. This one can be factored too. Are there numbers that multiply to be 9 that add to be 6? Yeah, 3 and 3. But I want to show you the discriminant, just to show you this. If I just check b squared, which is 36, remember that discriminant, b squared minus 4ac, so negative 6 squared is 36, minus 4 times 1 times c. Well, 36 minus 36 is 0. That means I should get one real solution. Well, let's do this now. If I factor this, x and x, numbers multiply to be 9, add to be 6, 3 and 3. Both would have to be negative to get the negative 6. X equals 3 for both of them. So that is one real solution. Okay? So you can solve however you want, but I want you to understand that discriminant as well. All right, this one. If I can, I'm going to divide by that coefficient. Can do it, so I'm going to, what's that divide? Oh, no, I can't. Never mind. Let's divide by 2. All right, so I've got this. The quick way to see if this can factor is, I'm going to multiply 2 times 9, that's 18. Are there numbers that multiply to be 18 that will add to be negative 6? Let's see, 18, I could use negative 9 and 2, I could use, what else? Negative 9 and 2, negative 3, and negative 6 and 3. Nope, it's not going to work, is it? 2 times 3, nope, I don't think so. So what I'm going to have to do is I'm going to have to do the quadratic formula here. So I'm going to have to do x equals negative b, 6 plus or minus square root, b squared minus 4 times a times c all over 2a. Okay, so let's see what this is. This is 18 times 4. 18 times 4 is going to be 40, 32, 72. 36 minus 72 is going to be negative 36. Yep, all over 4. Notice this number here. This is an imaginary number. This is a negative. When I take out that I, I'm going to have an imaginary. And remember what happens. When I have those two imaginary solutions, that's when that discriminant is less than 0, which we just had. We should have no x-intercept either. Alright, so just simplifying this part right here is 6i, so I'm going to have 6 over 4 plus or minus 6i over 4, so that's going to be the same thing as 3 over 2 plus or minus 3i over 2. Those are our two solutions. We have solutions, it's just that our solutions are not real. Just to show you this graph, I'm just going to put in 4x squared minus 12x plus 18. Here's the way it looks, and it should not have any x-intercepts if we did it correctly. It's way up there. If I wanted to see higher, I can just extend that y max, and there it is. And I can see that it does not have any x-intercepts. All right. Moving on over here. Alright, they want us to try a couple more of these. So we're going to, this time though, we're going to find the exact and the approximate solutions. I don't know that we need to do all of these, but let's do a couple. Let's look at this one. Take it over here. Take that over there. It must be in the standard form here in order to be able to use that quadratic formula. So I left this here, took those both over. Alright, so now, using that quadratic formula, it's going to be x equals negative b plus or minus square root. I want to show you something here. Like, let's say you go to your calculator and you do, I'm doing b squared. Here's what I see a lot of people do. They're like, oh, I did negative 7 squared in my calculator. Why did it give me negative 49? Because your calculator follows the order of operations, it's going to do 7 squared and then put a negative in front of it. If you want to do negative 7 squared, you got to do this. That's what it is. Just a little thing. Alright, so we got 49 on that. B squared minus 4 times A, I'm just going to make that 16 times C, all over. 2 times 4 is 8. Alright, so now we've got 7 plus or minus 16 times 3 is going to be 30, 18, 48. So 49 minus 48 is just going to be 1. Oh my goodness. When I get this answer here, 8 over 8 and 6 over 8, my answers are 1 and 3/4. That means I should have checked to see if that could have been factored. If I multiply 4 times 3, I get 12. Numbers that multiply to be 12 and add to be negative 7 would be negative 4 and negative 3. That could have been factored. Oh well. Here we go. Number 6. X squared plus 8x plus 3, negative b, plus or minus square root b squared minus 4 times a times c is 12, all over 2 times a. So we're going to have negative 8 plus or minus 64 minus 12 is going to give us 52, all over 2. 52 is 4 times 13. So this is going to be negative 8 plus or minus 2 radical 13 all over 2, which is negative 4 plus or minus radical 13. These are my two exact answers. Now if I want to quickly get my approximate answers, let me show you what we can do here. We're going to type in negative 4 plus radical 13. Get that. Now what I can do is I can just go back up and grab that and then just edit it and make it subtraction. And there are my two approximate answers. So those are the two exacts. The approximates are x is approximately negative 0.394. We'll go up 3 decimal places. And negative 7.606. Okay, so exact and approximate. Okay, we're not going to do number 7, same concept. Let's go on down here to number 8. A baseball player hits a foul ball straight up in the air from a height of 4 feet off the ground with an initial velocity of 85 feet per second. Here's the formula. Oops, and the t has been forgotten. Put that t in there. It needs to be v sub o t. Alright, write a quadratic function that represents the height of the ball t seconds after it hits the bat. So if I'm going to do this, then I need to substitute in for that initial velocity and that initial height. V sub o means the velocity at time 0, height at time 0. So we are going to have to plug in 85 for V sub o and 4 for that initial height. Because the ball's going up, we call that velocity positive. If I threw the ball down like that, that would be a negative velocity. Here's our function. H of t equals negative 16t squared plus 85t plus 4. Alright, got that part. When is the ball 110 feet off the ground? Well, that's asking us when is the height 110. I could plug in 110 here and try to solve it. A lot of work there. When I have a problem like this, one of these types, I always just use a graphing calculator. I'm going to have to put in negative 16x squared plus 85x plus 4. into y sub 2, see, here's what I'm doing. My height needs to be 110. So I want for this to equal 110. So I'm going to put 110 into y sub 2. Now, if I'm using a y value of 110, I'm going to have to change this window. I want to be able to see 110, so I might even want to make this 160, just to see. X's are time. We can't have a negative time. We might as well just call it, oops, not that. Might as well just call our y min 0. Let's see what happens here. All right. So what's happening then is the ball is going straight up in the air. Here's when it's 110. So I'm just going to find those points of intersection. If you can use a calculator, use it. Why take the time trying to solve that with the quadratic formula? And I know that sometimes your book is going to say to solve it with the quadratic formula. You know, when you do this problem on big ideas, they might say to solve it that way. But I'm never going to tell you how to solve a problem. You can do it the fastest way. It's not like in life somebody's going to say, hey, you have to do this problem the way I want you to do it. You do it the way that gets done the quickest. As long as you're careful, do it right. Okay, so at 2 seconds and at 3.3125 seconds, that's when it's going to be 110 feet off the ground. And explain your reasoning, we looked at a graph. Okay, the catcher catches the ball 6 feet from the ground. How long is the ball in the air? All right, well, here's what we're looking at. Remember, the ball starts off at 4 feet off the ground. It's going like that. So 6 feet. Okay, let's see what this is. So I'm going to have to change this now to 6. Let's get rid of that. Because now I want to know, when is the ball's height 6 feet? So I'm going to do, let's graph it again. 6 feet is going to be pretty low, but that's okay. Kind of hard to see it. Now he's not going to be able to catch it right there. A catcher doesn't catch the ball on the way up. Like, here's the ball going up. Oh, I caught it. No, that doesn't typically happen. They catch it on the way back down. So we're going to find that point out here. And 5.28, we'll round to the nearest hundredth. So 5.29 seconds is how long the ball's in the air. All right? So again, we talked about the discriminant. Remembering that discriminant is that b squared minus 4ac. It's just that part under the radical. Make sure you know these 3 cases. And then we also know the actual quadratic formula. Make sure you know that by heart. And then how to apply it. And again, use your graphing calculator whenever you have something that's like exceptionally large numbers. I don't want to go around doing negative 85 plus or minus 85 squared. It takes too long. All right, that's it.